Here's an inside look at the Hydra 400 automatic transmission. It automatically selects the best gear ratio and torque output for engine speed and load conditions. And it's not as complicated as it looks. Think of the transmission as three separate systems. First, the torque converter. It simply couples the engine to the gear train and multiplies engine torque output. Second, the planetary gears. They multiply torque through a series of different gear ratios. And third, the hydraulic system. It automatically engages clutches and bands to operate the planetary gears. Let's examine the planetary gear set more closely. In addition to multiplying torque, the planetary gears provide the basic means for gear reduction, direct drive, and reverse. The set consists of a sun gear, planetary gears or pinions, a planet carrier, and an internal gear. By holding one member of the gear set and turning the others, various gear ratios are possible. For example, a simple gear reduction occurs when power is applied to the internal gear, colored green, while the sun gear, blue, is held stationary. This causes the planetary gears, yellow, to turn clockwise and walk around the sun gear. Output at the carrier is clockwise. This shows direct drive. When any two members of the gear set are locked together, they force a third member to turn at the same speed. Notice that the pinions, yellow, do not rotate. Instead, they act as wedges that lock the entire planetary gear set into a single rotating part. For reverse, the carrier, brown, is held while power is applied to the sun gear, blue. This causes the pinions, yellow, to act as idlers, which drive the internal gear, red, in the opposite direction of the sun gear. We have mentioned that clutches and bands are used to operate the planetary gears. Let's take a look at how these clutches and bands work. Clutches and bands are the reaction or holding members that make it possible to shift gears automatically. The Hydra 400 has one-way clutches, bands, and multiple disc clutches. Make it a point to remember that clutches are applied by a hydraulic piston. Bands are applied by a hydraulic servo. Not all clutches are used to transfer power. This is a one-way roller clutch. It's used to provide a locking action. Notice the rollers between the inner and outer races and the accordion-like springs holding the rollers in a neutral position. Clockwise rotation of the outer race is possible. However, counterclockwise rotation will lock the rollers between the inner and outer races and prevent rotation. Bands also are holding members. They wrap around drums to hold one member of the planetary gear set. Applying a band is almost like applying a roller clutch with one major exception. While the roller clutch allows rotation in one direction, band application stops rotation in either direction. When bands are released, drums can freely rotate clock or counterclockwise unless held by a roller clutch. Our third holding member is the multiple disc clutch. It has fiber plates installed between steel discs. To apply this clutch, hydraulic pressure forces the clutch piston to compress and lock the fiber plates and steel discs together. When applied, this locks a member to the case. This is the location of clutches and bands in the Hydra 400 transmission. Let's see what happens when different clutches and bands are applied in each gear. In neutral, and while the engine is running, note that clutches and bands are off or not applied. Moving the shift selector to drive applies the forward clutch. This clutch remains applied in all forward gears. Torque reaction applies the low roller clutch. This gives us low gear. In second gear, the forward clutch remains on. When the intermediate clutch is applied, torque reaction engages the intermediate roller. With these members active, the low roller is forced to overrun. This produces a 1-2 shift. Shift speed depends upon the axle ratio, tire size, and rate of acceleration. In third gear, the forward clutch remains on, as in low and second. When the direct clutch is applied, two members of the gear set are locked together. This produces a 2-3 shift. Since the intermediate clutch remains on, the intermediate roller is overrun as well as the low roller. By manually selecting first gear, position 1, forward clutch, rear band, and low roller clutch are applied. The rear band keeps the low roller from overrunning. This provides engine braking in low. In manual second, first gear is the same as first gear drive position. In second gear, the front band and intermediate clutch are applied. Torque reaction engages the intermediate roller while the front band keeps the intermediate roller from overrunning. This provides engine braking in second. Selecting reverse gear on the shift quadrant applies the direct clutch and rear band only. This chart summarizes the application of clutches and bands in each gear. Note that the forward clutch is always applied in any forward gear. Also note that the low roller clutch is used for first gear only. This chart can be a very helpful troubleshooting or diagnostic aid. We'll see how it can be used to advantage after we examine hydraulic operation of the Hydra-Matic 400. The operation of the hydraulic system is controlled by a governor, a vacuum modulator, and valves in the valve body. The governor is driven by the output shaft of the transmission. The vehicle's speed signal that affects shift speed is supplied by the governor. In operation, line oil pressure, red, is fed to the governor. As the governor rotates, weights act on the valve, controlling governor output pressure, blue. Governor output pressure is proportional to vehicle speed, about 1 pound per mile per hour, or 60 pounds at 60 miles per hour. We said that the governor provides the signal in response to vehicle speed for the shift to take place. However, when accelerating under heavy load, a higher shift speed is desired. To make the transmission shift at higher speed, a variable oil pressure, called modulator pressure, is used. Engine vacuum regulates modulator pressure. Here's how. Low engine vacuum allows spring pressure to move the modulator valve to the right. This increases modulator output pressure, yellow. High engine vacuum will overcome spring tension, moving the valve back to the left, lowering modulator pressure. This graph shows how modulator pressure controls line pressure. For example, in drive under high vacuum or light load, modulator pressure is low, or about 60 pounds. As the load increases, such as wide open throttle, vacuum lowers and modulator pressure increases to about 150 pounds. We'll shortly describe how modulator pressure controls the 1-2 and 2-3 shift under heavy load, and we'll also see how this chart may be used to diagnose transmission problems. But first, let's examine the third major component of the hydraulic system, the valves and valve body. The main components in the valve body are the manual valve, 1-2 valve train, 2-3 valve train, 3-2 valve train, 1-2 accumulator valve train, and the detent valve train. Compare the valve body to a brain because it does make decisions or reacts to 3 inputs. First, the manual valve selects park, reverse, neutral, drive, manual second or manual first gear. Second, the governor input is in response to road speed. And third, the modulator input responds to light or heavy engine loads. Now let's put the system together and see how the governor, modulator, and valves operate in each gear. While the engine is running, and with the shift quadrant in neutral, power is not transmitted from the engine to the output shaft. Note that line pressure, red, flows from the pump to the pressure regulator valve. This controls line pressure. When pump output exceeds line pressure needs, the excess, red, white, is redirected to the pump intake by the pressure regulator. Line pressure, red, is also directed to the modulator valve and through the manual valve to the front servo, preventing band application. Whenever the engine is running, oil, pink, is also directed from the pressure regulator to fill the torque converter. From the converter, this oil passes through a transmission cooler into the transmission lubricating system. Modulator pressure, yellow, acts on the pressure boost valve and 1-2 accumulator. Modulator pressure passes through the detent valve and 3-2 valve to the 2-3 and 1-2 valve trains. Modulator pressure at the valves holds the valves closed. With the shift quadrant in drive, the manual valve allows line pressure, red, to apply the forward clutch for first gear. Line pressure at the governor is regulated to governor pressure, blue. As vehicle speed increases, governor pressure also increases, acting on the ends of the 1-2 valve and 2-3 valve. Line oil pressure at the 1-2 accumulator valve is also regulated to produce 1-2 accumulator pressure, green. Accumulator pressure, green, controlled by modulator pressure, yellow, is applied to the rear servo, which releases the rear band. Only the forward clutch is hydraulically applied, and the low roller clutch is effective. To initiate the 1-2 shift or into drive, second gear, governor pressure, blue, is applied to the end of the 1-2 shift valve and acts against modulator pressure, yellow, and the spring holding the 1-2 valve closed. As the 1-2 valve train opens, line pressure, red, seats a check ball, passes through an orifice, and applies the intermediate clutch. The intermediate roller is effective, which shifts the transmission into drive, second gear. For smooth clutch application, line oil pressure, red, moves the rear servo accumulator piston against 1-2 accumulator oil pressure, green. Line oil pressure keeps the front and rear servos from applying bands. As vehicle speed increases, the transmission will shift from second to third gear by applying the direct clutch. The forward and intermediate clutches remain on as in second gear. Here's how the shift to third takes place. First, increasing governor pressure, blue, at the 2-3 shift valve overcomes valve spring and modulator oil pressure, yellow. The 2-3 shift valve moves, applying line pressure, red, past the ball check valve to apply the direct clutch. Line pressure at the 3-2 valve moves against modulator pressure, yellow, cutting off oil pressure at the 1-2 detent valve and 2-3 modulator valve. For smooth clutch apply, line pressure at the bottom of the front servo absorbs some direct clutch application pressure and allows a smoother shift. This is a good point to further examine modulator control of shift points when accelerating under heavy load. Remember, low engine vacuum means high modulator pressure. High vacuum, low pressure. Here, modulator pressure, yellow, is directed to the 1-2 valve regulator to keep the 1-2 valve closed or in a downshift position. Modulator pressure at the 2-3 modulator valve holds the 2-3 valve closed, also a downshift position. In this way, the shift points to second and third are delayed to take place at higher speeds or when governor pressure, blue, overcomes modulator pressure. When the selector lever is moved to second, the manual valve directs line pressure to the 2-3 shift valve. This downshifts the transmission from third to second gear. The forward and intermediate clutches remain on, and the front servo applies the front band for braking. The intermediate roller is effective. The force of line pressure at the boost valve will raise line pressure at the manual valve to about 150 pounds. This increased pressure provides greater band holding power. Moving the shift quadrant lever to first will provide maximum downhill engine braking at speeds below about 30 miles per hour. In manual first, the transmission operates similar to drive first gear, except that the rear band is now applied for engine braking. For smooth band application, line pressure is applied to the rear servo piston and 1-2 accumulator valve. Line pressure at each end of the detent valve forces line pressure into detent and modulator passageways, blocking out detent and modulator controlled shifts. Line pressure at the 1-2 regulator and 1-2 detent valve overcomes governor pressure, blue, and the line pressure at the 1-2 shift valve. In this way, the governor will not cause an unwanted shift into second gear because of vehicle speed. For more hold power in first gear, line pressure is applied to the boost valve, regulating line pressure to about 150 pounds. Next, let's take a look at what happens when reverse is selected. The manual valve is repositioned to allow line pressure to enter the reverse circuit. Line pressure is applied to the 2-3 shift valve and to both areas of the direct clutch piston, applying the clutch. At the same time, line pressure to the rear servo seats a check ball, forcing the rear servo piston to apply the rear band. In reverse, line pressure is increased to about 90 to 240 pounds, depending on vacuum at the modulator. The line pressure, red, and modulator pressure, yellow, acting on the boost valve, is what increases the line pressure range. In the description of hydraulic circuits, it was repeatedly pointed out that line pressure is what controls transmission operation. It becomes logical, then, to diagnose many common transmission problems by checking line pressure and comparing results to a line pressure chart. We also explained earlier that the clutch and band application chart can be a good aid in identifying a faulty circuit or part. Let's put this concept to use in diagnosing a few example transmission problems. Looking at the clutch and band application chart, any problem occurring in all forward gears would identify the forward clutch circuit as the likely cause. It's the only component common to all forward gears. If the problem appears in first gear, manual, and also in reverse, the rear band is a good possibility to investigate. Using the process of condition evaluation and circuit elimination is all that's necessary to use this chart. But there are more uses to consider, and that's using this chart with the line pressure chart. First, to determine line pressure, a 300-pound capacity oil pressure gauge is installed in the pressure port on the left side of the transmission. Then, the vehicle is operated in each range on the shift quadrant, and pressure readings are observed. This line pressure chart shows readings for normal operation and how engine vacuum affects line pressure. Two mechanical conditions that pressure tests won't uncover are a faulty intermediate roller or low clutch roller. Assume that an operational problem appears in drive, second gear, indicated by a low pressure reading, but does not reappear in manual second. Let's cross-check this information against the clutch and band application chart. The difference between drive, second gear, and manual second is application of the front band. The intermediate roller is in drive, second, and manual second, but it does not provide a line pressure reading. This isolates the problem to the intermediate clutch circuit. The forward clutch is eliminated because the problem did not appear in any other forward gear. Other clutches and bands are not used in drive, second, and manual second. Diagnosis of transmission problems can be much easier by using the line pressure and clutch band application charts. This wallet-sized pressure clutch band application card has been included in this film release for your use. Put one in your pocket and use it during your next transmission problem diagnosis. And when you identify the cause of the problem, then it's time to use your technical service manual. If you find it necessary to disassemble the transmission, the bench chart furnished with this film contains detailed step-by-step instructions and photographs describing disassembly and reassembly procedures. It's like we said, the Turbo Hydra-Matic 400 transmission isn't that complicated. It's three systems that are related for proper gear selection. Understanding these systems will make your skills easier to apply.